It's 19 members, so I think it's a good number to start. So let's not waste the time. So let's start. So before we start, can anyone explain what we have discussed yesterday quickly? Just the highlights.
Yeah, CAN bus control, how to is working and CAN control CAN.
Mm-hmm.
So data receiver, CAN trans receiver,
Mm-hmm.
data structure,
Data structure. Okay, data
and
frame
standard.
structure.
Yeah, right.
Mm-hmm. Very good.
And bus register.
Yes. So we have discussed first of all what is. Oh, it is not writing. One second, guys. Huh, it's working. Okay, so first we have discussed. One second. Huh. We have discussed what exactly protocol meaning, and then we discussed what is communication protocol meaning, and then we have discussed why communication protocol, what was the history, and then we have discussed type of like type of communication protocol other than CAN, and then we have discussed why exactly we are using the CAN protocol and features of CAN protocol. We are still in between of features of CAN protocol, and we know that it is a standard. Like why, or like what and all is exactly standard meaning in the when it comes to the protocol. It is not only this one, every protocol is a standard. Okay, so and then what else? Sorry. What else we have discussed? And then we have discussed data frame structure. So in this data frame structure, there are two types: standard data frame and extended data frame. What is the main difference? The identifier. And we have discussed data frame and also the remote frame. Correct, right? So all these things we have discussed. And then let okay, you guys can see my screen. So we are okay. I gave one of the homework also. So can anyone explain me, please? OSI model, 7 layers. I mean, I don't need an explanation for each and every layer. I just want to know what are the 7 layers are applicable.
Yeah, okay, physical layer.
Mm-hmm.
From down to and up to the okay, data link layer,
Mm-hmm.
network layer,
Mm-hmm.
transport layer. This is the heart of OSI. Okay.
Mm-hmm.
After that, okay, we will get now session layer.
Mm-hmm.
After that, presentation layer.
Uh-huh.
After that, application layer.
Okay, very good. So I hope everyone heard the names of 7 layers. So basically, when it comes to the hardware or software, whatever you take, it will be categorized based on the layers. This is like based on the OSL layer. So as per the CAN protocol, like what do you think? What comes under physical layer? Can anyone just give me the example? What comes under physical layer? If anybody knows what is physical layer.
It's actually transfer data in binaries in 0 and 1. Okay.
Mm-hmm. No, I'm asking only about the physical layer now. Okay, so the first of all, the thing is, CAN is applicable. It's not applicable for all the 7 layers. So it is categorized only with the physical layer and the network data link layer, sorry, and the application layer. That's it. So in the physical layer, the CAN bus and the CAN transceiver comes under the physical layer. Okay, so it is just a categorization which they have made it, and you cannot see anywhere that what like where I can see the physical layer. No, it's not a valid question. So the physical layer, it's like the name and the what I can say the stage of the CAN bus and the CAN transceiver and all the hardware components you use it. And as we know, these two wires, the complete CAN bus and the connectors what you use, everything comes under the physical layer. Okay, and CAN controller comes under the data link layer, And in the application, it's the application completely wherever if you have the microcontroller or the display, like what we have discussed on the dashboard, or any other sensor. It's like a complete application layer. So where exactly, if you are using any tool, if you are seeing the can messages, that is an application. So typically you guys will be working on the application layer, not on the physical layer, or on the neither on the data link layer. Most probably, if you have any updates, like only as a developer you will be updating only the can frames and the signals inside the can frames. Okay. And also, if you are going to be a tester, you will be working on the physical layer as well. Depends on the project which where you get into. And you will be working on the application layer and the physical layer. Okay. So whoever gets into the testing of physical layer, they should be aware of completely the what is the CAN bus, the voltage, how it converts, the CAN transceiver, everything you should be aware of those things properly. Okay, for the development, it is not at all required because CAN has been developed very long back and you don't have to worry about it. Your only job will be on the, most of it is on the application layer, where you will just configure the signals with your variables which you have coded in the development, nothing but which you have used in your developed code. Okay, that's it. So then, okay, coming on to the CAN frames. What are the frames we have discussed yesterday? What are the frame data structure, frame structure we have discussed?
A tree.
Yes. Yes, what we discussed. Which
Standard data
frame?
frame and extended data frame.
Hmm. So in that,
That's
that is a data frame, right? That is a data frame.
yes.
And then which frame we have discussed?
Starting start of the frame.
Start of the frame is the structure of a data frame.
Yes, yes,
Request or remote frame also we have discussed, right?
yes, yes.
Okay. So these are the
Sure.
two types of frames we have discussed, data frame and request. Out of these two data frames, we were discussing only the structure of data frame, and we have not completed yet. In this data frame, we have the two types of frame structure. One is standard, another one is extended. Correct, right? Standard is 11-bit identifier, extended is 29-bit identifier. We are still in this stage, and I am gonna continue with this like where we have stopped. So any questions so far?
Yeah, no.
Okay. So then let's continue. We were in the start of the frame, we discussed arbitration field, we have discussed control field, discussed data field, discussed CRC field, acknowledgement only, positive things discussed in these two. Okay, so now I would like to consider the CRC field, and then we'll go for the acknowledgement field. So as I already explained, what is the CRC field? What exactly is happening in the CRC field? So I mean, I didn't explain completely how the CRC is calculating and all, but I had explained what is that. What is that meaning? CRC field is for what? What purpose?
CH store of 1 byte, right?
Uh-huh. Sorry.
It is storage of 1 byte, right? CRC.
1 byte. 1 byte. You can see. What's the size?
Sorry. It's art here.
Even that's not 1 byte. There is a difference between byte and bits, and I hope everybody knows what are bits, what is byte. Okay, so the first of all, CRC field which we have discussed, it is to identify the like if ECU A is getting the input from the ECU B, so how the ECU A understand that I have received the proper data and from the ECU B. That is the reason we like there should be a confirmation, right? If I am getting some information, I would need a confirmation that it is a right right information which I am getting. So similarly here also, so the ECU will be getting a confirmation that I have received a proper input or not. Using this like to check that there is a size of 15 bits which has been applicable for the CRC field. So CRC is something like a cyclic redundancy check. So as the name suggests, it is a checking. Okay, whether I have received proper data or not proper data. That's what we are checking. So how exactly it is calculating? Let's go how exactly it is calculating. So in the CRC field, what happens? As we know, the frame starts with the which field? The frame start with the, come on guys, I'm expecting answer. Start of the frame arbitrization and control field. In the arbitrization, we have the 11-bit identifier and the RTR bit, which is 1 bit. And here it is 11 bit. So from the starting here, you have sent the 11 bit, which is like, for example, of 143, and it will be configured inside the software. You don't have to worry about it. It will be always dominant in the standard data frame. And then in the control field, which is the starting field after RTR. Hello.
It's like 29.
After RTR, which is the bit in the, what is the first option in the control field? What is the field like what is the name of the bit in the control field? The first one.
ID.
IDE. And what is the default value of IDE in the standard data frame?
Dominant.
Very good. And then DLC, assuming 7 bytes of data, and then the data field where we can send the 8 bytes of data in a single frame. Okay, so by considering each and every bit which has been transferred by the transmitter, here the transmitter is ECU A. Okay, what is transmitter meaning? Someone is transmitting that. So in our case, I am the transmitter, you are the receiver. Whenever you are answering, you are the transmitter, I am the receiver. Okay, so one thing to confirm, every ECU works as both transmitter and the receiver. Okay, don't get confused. Every ECU which is connected on the bus network works as both transmitter and receiver. What does it mean? Every ECU send the data to the bus and every ECU which like receives the data based on its applicable. If that ECU is tend to accept the, can you please go on mute whoever don't have any questions? Okay. So every ECU works as both TX and RX. Nothing but ECU sends the output to the bus and every ECU receives the input from the bus. Okay. So in our example, we have the ECU A as a transmitter which is transmitting this data and will be receiver would be ECU B. Okay, so ECU A transmitting this much of data. So in the CRC field, what is happening by considering this every bit by bit, now I have written on the hexa, you have to convert them to binary. So whenever I say it's accepting like bit by bit, I hope you know what I meant by bit by bit. Okay, so the every bit by bit will be stored in the in the CRC field, and there will be algorithm for to check the there will be algorithm which will be used by the developers to check the what I can say the checksum. So what does it mean? What I meant by, okay, Give me 2 seconds. This I'm feeling difficulty in writing on this. Okay. The algorithm, it's typically based on the client request, which algorithm they want to use it. So it is not typically based on the developer. It is typically based on the client, which algorithm they want to use it. So you will be getting it could be a polynomial formula, one of the polynomial formula, or it could be a one of the algorithm which you will be getting it. Okay. So based on that you will be calculating the checksum. So how exactly you will calculate the checksum? The calculation of the checksum will be done by the bit whatever the transmitted so far from the transmitter to the receiver. One second please.
Hello.
Yeah, one second.
MGBS and put LB Nagar అని చెప్పు.
Can you guys please go on mute? Okay. So what we were discussing. Okay, so remember this is the data which has been transmitted by the transceiver. So you see, like based on the algorithm which you have developed to calculate the checksum, the input would be every bit which has been transmitted by the transmitter to the receiver. Okay, so now let us say this is the bus and this is the ECU A, which is a transmitter, and ECU B is the receiver. So as we got to know, like 143 is the identifier and the RTR and the IDE, and then like data complete one frame which has been transmitted on the bus and it's supposed to receive by the ECU B. So now whenever the ECU B has received this complete data, every bit will be used for the checksum calculation. This checksum will be calculated based on the algorithm or based on the polynomial formula, okay, which will be given by the client, which will be always not the same one, okay, which will be always different based on the project to project. So based on the algorithm, you will be calculating the checksum. The input to calculate the checksum is the data which has been transmitted by the one of the ECU, which is a ECU A in our example, which will be received by the ECU B. So when it is calculating the checksum, which will be stored under the CRC field. So what happens once after you shared the once after the ECU A has been transmitted the value on the bus, nothing but a frame on the bus, that time ECU B receives the data and calculate the checksum based on the input it has been received. At the same time, ECU A also calculates the checksum based on the data which it has transmitted. So what would be the checksum of ECU A and ECU B at the end? What it should be? Input is same, right? For ECU A also, to calculate the checksum, input is whatever the data it has been transmitted. For ECU B to calculate the checksum, what is the input? Whatever the data it has been received. Correct, right? So what would be the checksum? Would it differ or it would be same?
It would be same. It would be
Will be same.
Yes. So if the checksum is same, that time only the receiver will, like it will go for the next, checking, which is so once after the ECU A has been transmitted the data and ECU B has received the data and the checksum is matched, and then ECU A waits for the ECU B acknowledgement. Assume if the checksum didn't match. Okay, so if the checksum didn't match, what happens?
it's got a error detection.
Yes, since we do have the error detection, the feature in the CAN protocol, if it is not matching, we will get the CRC error. This is one type of error. You have to remember this. Whenever we go for the error, I will be asking, because I will not explain this concept again. So clear?
Yeah, clear.
Okay. So once the checksum is now comparison between the checksum between the ECUs has been like it's matched. Then it will go for the acknowledgement field. So where the acknowledgement field default value in while sending from the ECU, it will be recessive in the acknowledgement field. Acknowledgement field is only 1 bit data. So in that acknowledgement field, the value will be recessive whenever it is transmitted by the transmitter. So once after the checksum is once after the calculated checksum is matched with the ECU A, once after B is received the data, the ECU A will wait for the acknowledgement. What does it mean? How exactly ECU B is sending the acknowledgement? It is not sending some value to that. It will be how it is acknowledging. It is gonna acknowledge the by updating the acknowledgement field to dominant. Before, whenever ECU A was sending the data, acknowledgement field used to be recessive. And then how ECU B is acknowledging that I have received your data by updating this field to dominant. If it is not dominant, if it is still a recessive, then what it will happen? Nothing but ECU has not acknowledged that any other ECU in the network has not acknowledged that I have received the data. So what happens if any ECU is not acknowledging you, or acknowledging to the transmitter? If I am asking the question, if you guys don't answer, what I will do? What happens for me? I'll stop the class, right? I will not continue if I'm not getting the expected answers or expected response, I would say, not the answer. Correct, right?
Yeah.
So similarly, the ECU also, if it is if the ECU transmitter ECU, if it understand that nobody has received my data, then what happens? It will create a error, which is the acknowledgement error. Clear? How it is acknowledging and how it will create the acknowledgement error. If the acknowledgement field is not getting updated to dominant by the receiver, it's gonna create the acknowledgement error. If it is updating, if the acknowledgement field is getting updated from the receiver to the dominant, which means so the frame has been received by the ECU and it is acknowledged. Otherwise, it will create the acknowledgement error. You will keep on seeing the error, like acknowledgement error, acknowledgement error, acknowledgement error. You will not get the, any message from the ECU. Clear? Or any doubt? If any doubts, please ask me. Please do not wait. If no answer also for after 10 seconds, I would assume it is clear. Is it clear or not?
Yes, clear.
Okay. Okay, so the delimiter, acknowledgement delimiter, I will explain when I explain one of the errors, so it will be easy, and even the CRC delimiter. So end of the frame intermission we have already discussed. Now I need everyone's attention, please. Now you guys have to tell me what are the difference between the standard and extended data frame format. I'm not going to explain it. So in the extended and standard data frame, what do you see? Start of the frame. What is the default value of start of the frame?
11 bit.
Sorry, what is that?
11 bit.
Uh, arbitration field.
I am asking about the start of the frame.
7-bit identifier.
I'm
It will be
asking
dominant.
about start of the frame. Yes, it is dominant.
It is a
Okay,
one bit
so
data.
please,
It is
yes, it is one bit data, and the size of start of the frame is 1 bit, and default value is dominant. Don't get confused between the start of the frame and the 11-bit identifier. Clear? Okay.
Ma'am, repeat once.
Who is that?
Yeah, Ravi.
Yeah, Ravi. So, what did you understand about the start of the frame? Did you understand anything?
Uh, yeah, but no, ma'am.
Okay. What is the start? I mean, you know the meaning of start, right?
Yeah,
And frame. So we are talking about what? Frame structure, frame format only we are talking about. Frame is what? It's a like the structure of data, how the data should be. It's a frame. Correct, right? The multiple data in the in line, it's called a frame. So there is a standard saying that data should be construct in this way or transmit in this way. Correct, right?
okay.
So how it has to start? That is the start of the frame. There should be a starting point, right, for everything. Even though if you take in general, there should be a starting point. Correct, right? So similarly here also, to start the one frame, we have the start of the frame where it will be always dominant. The size of start of the frame is 1 bit. Why it is always dominant? Why not recessive? Any idea why not recessive? Why it should be always dominant? Anyway, we have discussed why the RTR should be always dominant and IDA should be always dominant for the standard. Now my question is why the start of the frame should be always dominant? Any idea, anyone?
Should start with more power, right?
Okay, so very good. So what happens if you give the recessive? Bus will not be active. Okay, so because it is a dominant, because like dominant wins the priority over the recessive. So if any of the one ECU, if it is sending the data, then only bus will be active. It's like a kind of power for the bus. If none of the ECU which are connected to the bus, if none of the ECU sending the data, then of course bus will be idle. It will not be active because there is no work for it to do. Correct, right?
Yeah.
Yeah. So the next is in the extended data frame format. I hope Ravi, your question is answered.
Yeah, okay.
Okay. So the next is 11-bit identifier. So do you see any difference between the after the start of the frame from the standard and extended till the 11-bit identifier?
Yeah, little bit is there, right?
What is there? I am just asking till the 11-bit identifier.
Nothing is okay, but in standard, okay, it's attribute. It's combination of control field and data field, right?
No, we didn't go for the control field yet. It's fine. I'm still in the 11-bit identifier. So you don't see any difference. You have only start of the frame and 11-bit identifier. Correct, right? That till there it is arbitralization field in the standard, but in the extended it still have. That's what we will see next. Okay, so after the 11-bit identifier, what we have in the standard RTR. So what we have in the extended, it is SRR. So what is the default value of RTR?
One bit.
One,
One na.
yeah,
One means what?
1 bit.
And I'm not asking about size. See, there is a difference between the size and the default value. Both are not same. Size is, it's a size. I don't know what to say the other than size. Like the size synonyms, I don't know. Size means like how many memory bits have been assigned for that particular um, field or for that particular action. So when I say the default values, what is the default value which is present on that particular memory? Now I'm asking what is the default value of this RTR, not the size.
It will be dominant.
Very good. Why? We have discussed yesterday. Come on, guys. Why it should be dominant? There should be a reason for everything, right? There should be a purpose why they are making this as a dominant always. Like how we have seen for the start of the frame.
To active all ECUs from identifier, right?
To activate all ECU from the identifier.
Identifier, I mean, for everything we have some code, right, for identifiers.
No. We have discussed this one, right? Why RTR bit will be always dominant. No one remember already? Okay. So what is the difference between the remote frame and the data frame? What is the full form of RTR? If you guys don't answer, class will not be moved on. Okay. So it's not my, thing to
Remote
continue
transition
without.
request.
Okay. So what does it mean? Why it is always dominant?
It will take this, first it will take the receive and transfer, and again it will receive from ECU.
Sorry, I didn't get you.
It receive data first, okay. After that, again it will transfer data.
Mhm.
After transfer, again it will receive the data from one issue to another issue. That's why it will be dominant.
Okay, so you I think you are whatever you're trying to say is correct, but it has a name. When you say the name, then only it will be understood by the everyone. It's a request. If you turn on the car, then only all the default active safety ECUs will be awake and it will start sending the data. Okay, so which is what does it mean? You are turning on the car, it's a request. Okay, so whatever the data is sending the data is a response, which is data frame. And whenever you are giving like the turning off the ignition is a request, which is a remote frame. Okay, we have discussed this yesterday. So what is happening here? So all the ECUs will be responding and it will not allow to accept the next request. So once the complete data frame is nothing but a response has been given, then only it is going to accept the next request. It is to dominate the response than the request. Understood? That is the reason it will be always dominant. Okay, so in the extended data frame, in the place of RTR, we do have the SRR bit. Anyway, we have the RTR bit also, which I am not going to explain because you already know what is that meaning. After this, RTR, control field, data field, everything is same. Only we have to see in this two, three, only SRR, IDE, 18-bit identifier. That's it. So what is SRR bit? Is SRR bit a substitute remote request. Okay, so which the size of this SRR bit is 1 bit, and the default you can write it down if you want. The default value of SRR bit is always recessive. Okay, so why it is always recessive? The purpose of having this particular bit to set to the recessive always to give the priority for the standard data frame when there is a same 11-bit identifier. And with the both the ECUs, okay, let's say in this way, you have one ECU A, one ECU B, another one ECU C. This A ECU configured with the standard data frame format. ECU B is configured with the extended data frame format. So now in the standard data frame format, we know it is 11 bit. In the extended, we know it's a 29 bit. But as you can see here, once after the start of the frame, it has the 11 bit, and then it has the SRR and then ID and then the 18-bit identifier. So assume now the 11-bit identifier in here, nothing but, let me write one example. In the standard, it is just, let me take an example of 143. In the 29 identifier, 14, 3, 30, 29, some x1. It's there now. So as you can see, the 11 bit, it's same, 143, 143. So if the ECU A and ECU B is sending the frame at a time on the bus, so who wins the arbitralization? Who gets the priority?
Standard will get the priority.
Why?
Uh, it is the main thing, right?
Due to the,
Main.
not due to the main, it is because of the
Standard.
SRR bit. Who wins the, like, if you remember, who dominates between the 0 and 1?
0 dominant only.
Yes, nothing but wins the prioritization. Dominant wins the prioritization over the recessive. Correct, right? So you are like, whenever I write 143, you have to assume 00001 and then 0100 is 4, 3 in the sense 0011. This is how it will be. Inside the software, this is what is happens. So, okay, for that I do have one of the slide itself so that you will understand. Here is arbitration. Yeah. So whatever you write, 143, if you write, this is how it will be. Okay. So 1000. If the ECU A is sending this data, if ECU B is sending this type of data, so it will be compared. Recessive, recessive, fine. Dominant, dominant, fine. Dominant, 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 dominant. Now one recessive and then dominant. So here who wins the prioritization? ECU A or ECU B?
B.
Yes. Why? Because it is recessive. Correct, right? So now this is withdrawn. ECU A is withdrawn. ECU B wins the arbitralization. This is how the priority identified. If the ECUs are sending the data at a time. That's what we are seeing here. Now ECU A is sending the standard configured with the standard frame. ECU B configured with the extended data frame. Both the ECUs are sending the frame at a time on the bus with the same 11-bit identifier. Who wins the arbitralization? Standard wins the arbitralization, which is nothing but ECU A wins the arbitralization. But why?
Because
Because
of
of
dominant.
S. Yes, because of SRR bit. The SRR bit is the purpose of having the SRR bit is to provide the prioritization for the standard data frame, because SRR bit will be always recessive. So by default, it will lose the prioritization over the standard data frame. Clear?
Yeah.
Okay. The next is IDE, extension, sorry, identifier extension. What is the default value of identifier extension in the standard data frame? Hello?
Standard can identify.
Hey, what is the default value? What is the size of this?
Yeah, 8-bit.
8-bit.
Identity.
No, it's a 1 bit of data
1 bit of
size. What is the default value in standard data frame? What is the default value? Okay.
Hexa, this one.
It's a.
Hexa
I'm
this
not
one.
asking about the identifier. I'm asking
Okay.
about the IDE bit.
ID bit.
Identifier is 11 bit. It's fine.
Okay.
It's clear. It's visible also. So I'm asking about the IDE, identifier extension. Okay, so in the identifier extensions in the standard data identifier, it is only 11-bit identifier. So the default value of identifier extension is dominant, not recessive. But in the extended data frame, it's a recessive because it has a extra identifier, not only the 11-bit identifier. So whatever we have the extra identifier, which is 18-bit identifier. Okay, that is the reason the IDE, which is identifier extension bit, will be recessive to get the extra 18-bit identifier. Okay, so the next is RTR. So R1, R0 don't have to worry, it's a reserved. Okay, you don't have to explain also. So everything is same except in the arbitralization field. So can anyone explain me what are the differences you have seen in the standard data frame and an extended data frame?
Yeah, okay. In standard, okay, it's dominant. Okay,
Which is dominant?
RTR is dominant.
Uh-huh.
In extended data frame, okay, SSR is receive.
Here also we have the RTR. In place of after the 11-bit identifier, we have the SRR bit. RTR value don't change because this is also a data frame. This is not the remote frame. Yes, please go ahead. From here, it does not change anything from the standard data frame. It's same. So now tell me what is the difference?
Standard data frame is 29-bit identifiers and extended data frame is 29 identifier.
You said both are 29-bit identifier.
Standard we have only identifier 11 bits and X.
Mm-hmm.
And another one we have extended format, it is in 29 bits.
Okay. What is the other difference?
Another differences we have as SSR in extended.
Mm-hmm. Yes, please go ahead.
SSR in extended format and other differences it is IDE, it is standard and extended frames.
I mean, you are not so clear, but anyway. Okay, so the main difference between the standard and extended, it's about the ID identifier. In the standard, we have only 11-bit identifier. In the extended, we have 29-bit identifier. And then next difference is SRR bit. There is no SRR bit in the standard data frame format, but we do have the SRR bit in the extended data frame format, and you guys are already know why and what is the default value of SRR bit. And other last difference is IDE bit. So the IDE bit will be always dominant in the standard, but it is recessive in the extended. So except these three, everything same, including the CRC field, acknowledgement field, data field, end of the frame, everything is same. So is it clear?
Yeah.
Okay, so that's what is explained in all this. Okay, so then now we have seen the response, which is a data frame, and we have discussed about the request, which is a remote frame. So there is only one difference between the remote frame and the remote frame or request frame and the data frame or response frame. Okay, don't get confusion. We have a request, we have the response. Request is called remote frame, response is called data frame. We have discussed about the data frame. Now what is the change in the frame structure of the request frame? There is only one change, which is there will be a no data field on the remote frame because it is just a request. It is not sending any data to any ECU. That's it. It's a request which will not be having any data field, like how we had here the data field to send the 8 bytes of data, which is the actual data which will be sent. That this field, data field, will not be present in the request frame. That is the only difference we have in the remote frame. And another difference is RTR bit, where what is the RTR bit default value in the data frame?
1 bit.
Default value?
Dominant.
Guys, I'm asking default value, not the size.
Dominant.
Yes. So it is a dominant, but in the why it is dominant, we have already discussed why exactly it is dominant, to get the to give the prioritization to the data frame always. So what happens in the remote frame? The RTR bit will be recessive, not dominant. That is these are the two difference only between the remote frame and the data frame. Clear?
Yeah.
Yeah. So now tell me, what is the difference between the data frame and remote frame?
In remote frame, okay, RTR is recessive, and in data frame, RTR is dominant.
Okay. Only one difference? Guys, I'm asking. Just now I explained two difference. What's the another difference?
In data frame, it's a request frame, okay, and
Data frame is a request or response?
response.
Okay, continue.
Remote frame is a request frame.
Okay. I mean, that's you gave the explanation. Guru Lakshmi? Do we have Guru Lakshmi online? Bhavya? Yes, please. I cannot hear you, Guru Lakshmi, if you are talking. Yeah, what is the difference between the data frame and remote frame? What is the another difference? One difference he already covered. Okay, cannot hear you if you are talking. Bhavya? Any Bhavya can answer. I mean, I have not, got any answer till now from girls' side. Only boys are active. Okay, Shweta?
Yes, remote frame is a request transmission of a specific data frame.
Mm-hmm.
On data frame is a response transmission of a specific data.
And I'm asking the difference. I just know we have discussed the difference between the frame structure of data frame and the remote frame, right?
Yes, one of the difference is remote is recessive and data frame is a dominant.
What is
It will
dominant? What is recessive?
dominant is a zero bits.
No, I didn't ask what is dominant. Like when I meant what is dominant, like which bit is dominant?
Can you check the screen? Can you check?
Okay. Okay, I'm repeating again. So I need answers from the next class. Please listen carefully. Classes will not be move on if you're not answering. Okay, it's not going to happen in my classes. So the difference between the remote and data frame you already know. When it comes to the like data frame structure, in the remote frame there will be a no data field. Okay, which you have seen in the data frame. Okay, where you can send the 8 bytes of data, which is a actual data. This data field will not be present in the remote frame, and this RTR bit is recessive in the remote frame format, not dominant. These are the two difference between the data frame format and the remote frame format. Clear? Okay. So far we have discussed only the data frame and remote frame. Along with the data frame and remote frame, we do have two more frames, which are third one is overload frame, fourth one is error frame, fifth one is interframe space. Error frame we will be discussing in depth in the errors, not now. So when it comes to the overload frame and interframe space we have already discussed. It's a delay between the one frame to another frame. There is no frame structure or anything for this. So that's the only information about this. So when it comes to the overload frame is something like, the bus, whatever we are discussing, which like where the nodes have been connected on this bus. So assume every ECU which are connected to the bus has, like, keep on sending the data on the bus. So the bus has to keep on prioritizing the data and will be sending and will be received by the ECUs. Okay, so now assume like 200 ECUs are keep on sending the data, and what is happening? It will be on the queue. Nothing but it will take the first like whatever has been received by the bus, and if the multiple ECUs are sending the data at a time, if this ECU A and ECU B sending the data at a time, so it will do the prioritization. Okay, now after this prioritization, ECU A wins the arbitralization, that message will be processed. Assume next is ECU B, which is, the data has been ignored because the prioritized data was from the ECU A. Now ECU C, ECU D, ECU A, like up to we have 200. Like that, assume all 10 ECUs are sending the data at a time to the bus. Okay, and now bus has to identify which one, like, by using the arbitrarization, it will identify which one to provide the prioritization out of 10, and 9 will be ignored, 1 will be considered. So next again, once it is ignored, it will not simply be there, again it will send, all 9 will be sent at the along with the 9, again there will be a 10 more. Okay, so when this is happening, the message, like, the next prioritization messages will be on the queue. It will keep on queue. So what happens? The capacity of the bus will be overload. So what happens? Whenever it is completely overloaded, it will send the overload frame. And there is no structure for this. It is just for the understanding purpose, but it is not used in practically usually. But this is the concept of overload frame. When the bus is completely overloaded, it will send the overload frame. Okay. So the next one is only the error frame, which we'll be discussing in depth. In the error frame, there are 5 types of errors. Out of five, you already aware of 2 errors. One is CRC error, another one is acknowledgement error. So the 3 errors which we are going to discuss. One is bit stuff error. Bit stuff error. Write down in this way. Bit stuff error. Bit error. And form error. What are the other 2 errors which I told you to remember?
CRC error,
Very good.
acknowledgement error.
Okay. So we have discussed these two. We will be discussing these three and what exactly happens when this error is flowing on the bus. Whether it will be active, whether the ECUs will be communicating with each other when there is an error on the bus, whether it will not be communicating. This we will see in the next class. Okay. So tomorrow, 8:30 to 10 o'clock. So do you guys have any questions or do you need this PPT for the revision purpose? Because I will be asking the question. I will not move if you guys are not answering.
One doubt, okay.
Yeah, please.
What is the main use of this overload frame?
Yeah, like main uses in the sense, as I told you, it's not used in practically. So like, okay, so you are working from morning to till like you have started working at 8 o'clock and you are still working at 12 a.m. in the night. So how you work like nothing, but how do you feel?
It's like burden. That's fine, okay. But what is the main purpose for this one? Implementing overload.
Yeah, because that is the reason the bus will be keep on accepting the messages, keep on prioritizing, and the queue is huge, nothing but limitless. So that time what happens? Bus cannot accept the next message from the ECUs. That time how exactly it is communicating to the ECUs that I'm exhausted.
Fine, fine.
That is why it provides the overload stating I'm exhausted. I cannot accept your frames anymore.
Fine.
Okay. Okay. So any other questions?
No.
Okay. Any others?
No, ma'am.
Okay. So in the tomorrow class, we will discuss these three errors and we will see a little bit more about the what I can say, the some scenarios. I will give some of the scenarios to understand whether you guys have understood the arbitrarization, nothing but a prioritization. So you guys have to answer those questions or scenarios. Okay. If there is no questions, we can end the session. Thank you. Bye bye.
Thank you, ma'am.
Thank you, ma'am.